Thank you. Now we'll talk a little bit less about pirates and a little bit more about VOD2Live, even though we might touch on the pirates again. So I'm Björn, and I work at Wowza, and I've been working with streaming platforms for a lot of years now. I think it's about 7 years, building and operating a streaming platform, which of course has been a lot of fun, and we've built some interesting solutions along the way. And one of those is a VOD2Live solution that has been solved with serverless and edge compute. So first, VOD2Live, what is it? Well, it is taking one of your already existing VOD assets and using it as a live stream. And first of all, why would you even want to do that? Isn't VOD a better thing for the viewer? They can see it whenever they want, they can skip ahead if they like, and all that is true. But think of linear TV, that has been popular for a long time, and that is mostly VOD2Live. Sometimes it's just live. Or pre-recorded live events. During the pandemic, pre-recorded conferences like this one was quite popular, so all the talks were pre-recorded and then broadcasted as live. Then, of course, for me, that might have been better because I would have to do 15 recordings before I was happy. Now I only have to do it once. And then when you do live, those of you in here do live, know there's a lot of things that can go wrong. If you do VODs, there are fewer things to go wrong. And we'll go through what you need to do to take a VOD and turn it into a live stream. And first a very basic use case, and then we'll add some more nice features to it. And yeah, as promised in the title, serverless. There are a lot of different options around, and we will be using some of them. CDN and edge compute. And the great thing about being here is that I don't have to explain CDN. Most of you know, pretty much all of you know what it is and what it's for, and we're distributing video, therefore we need it. And if we use the computing that is integrated into most CDNs, we get edge compute because it's not at the same place at once, it's spread out into the network. So a little bit more about serverless. Of course, see it as a quick introduction. And depending on how you define serverless, it has been around for about a decade now, and there are a ton of vendors, not just your normal big cloud providers. And if you listen to the marketing cry, it says sort of, don't think too much about servers, just run your code. And while that is oversimplifying things, it's pretty much true, actually. And the same thing goes for scaling. Someone else handles the provisioning and the scaling of the compute assets you need to run all of your code. Then, of course, as with all scaling, somewhere, somehow, there is a limit. So beware, you will hit it eventually. But all that said, automating your infrastructure and your deployment and your whole build process, that is still a very good idea. Nothing has changed there. There are a few differences, like the observability is different, and sort of debugging it, finding errors are different, and sometimes harder when you're not used to it. And it's not just compute that you can do serverless. You can do serverless almost anything, but for our purposes here, we need serverless databases as well, for the very simple reason that most solutions need to keep state somehow, somewhere, and this one is no different. And you can't really talk about serverless without talking about the costs. Some people say it's really cheap, some people say it's very expensive, and they're both right. The basic use case is really quite simple. For costs, it's like most things in the cloud. You pay for what you use, but what on earth does that mean? Well, take the case of compute. You just pay for the execution time you have, which is essentially the same as paying for CPU cycles. And if you use serverless, those CPU cycles are not the cheapest ones you can buy. If you buy an entire instance, the CPU cycles are cheaper. But the thing with serverless is that usually you get rid of idle. There's absolutely no idle at all. So you can have something ready to go, but there's no traffic, there's no cost. So for some applications, really useful and can be really cost efficient. For others, not so much. But yeah, there's still no silver bullet for anything, but it's another useful tool in the architecture toolbox. So, VOD2Live, you can even see it, awesome. So what we want to do is that we want to create a live from our VOD, and we want to do that without running a transcoder again. And luckily for us, there is a way to do that by manipulating playlists. And that is very efficient from a sort of compute point of view, which means it's effective from a cost point of view and from a power consumption view. So both sort of finance and tech can be happy about something at the same time. And starting with VOD, we have this master playlist. And then you wonder sort of, okay, is this a VOD or a live playlist? And the simple answer is that you can't really tell because they look the same. It's a list of the media, it's a listing of the media playlists available. And for us, that is a very good thing because we wanted to take a VOD and turn it into a live. So for the media playlist, we're already done. Or for the master playlist. The media playlist looks something more like this. Should be familiar to most of you. It's a very basic HLS playlist. And we want to turn that into a live media playlist that can look something like this. And there are a few differences between them, but not that many. First is that the VOD has a playlist type VOD, unsurprisingly, and also an endlist tag. And then in the live playlist, you see that there is no playlist type, because interestingly, the HLS standard, there is no type VOD. There is a type event, but that is more for DVR purposes. And that one isn't super important. It's what you can, if you can add and remove from the playlist. Then we have the discontinuity sequence in the live playlist, which has to do with discontinuity tags, and we will get back to those later. So, and then, while they are very similar, there is one more important difference between them, and that difference is time. The VOD playlist doesn't care about time. It's constant over time. It's always the same. While the live playlist obviously changes with time. There are a certain number of segments available at any given point in time. So I like to look at it a little bit like this. How do we turn our VOD playlist into live? Well, imagine a window that sort of scrolls down the playlist over time, and whatever you see in this window, those are the segments that goes into your live playlist. So here, at time 0, it's segment 1 through 6, and then if we move along to 8 seconds in, if you then ask for the media playlist, you will get 2 through 7, and another 8 seconds in, it is segments 3 to 8. So, and that's because we have 8-second segments, and so on. The playlist changes. And some of you probably picked up that we could easily turn this into DVR if we wanted to, by just adding new segments and not removing the old one. So now, how do we solve this or build it? Well, this is a little bit of an illustration. And first, let's talk about the parts. We have our CDN, in our case CloudFront, and then we get to the serverless part, which is the Lambda edge that is integrated into CloudFront. And that one can be triggered on different events. For us, the really interesting one is when we have a cache miss, so then we can run our compute. Then we have DynamoDB to keep a little bit of state, and that is our playlist info. And there's a handy service called Global Tables, so we can have it automatically synced to any data center that we want. So the flow is that the player requests the playlist from the CDN. There is a cache miss, triggers our compute. That goes to DynamoDB and fetches the playlist information. The playlist information, in short, contains the start time of our VOD, or a live when it should start, and then a list of all the segments that are included in the media playlist. Together with the current time, we can then decide where to put the window and which segments to generate. And so here we have a distributed solution, which means hopefully lower latency for the user and a little bit less operations for us. Now, we want to add some more features. We want to have some basic programming, not just one VOD, but a whole playlist of VODs. And then I want the playlist to look a bit more live and basically hide the underlying VOD assets. And we can do that by changing the segment names and tricking some with the path. Then, since most segment names are predictable, we would also like to basically hide future content that hasn't happened yet, because no one should be able to see into the future. That's very powerful for anyone, so don't do that. And in practice, let's say that you have some common information that you want to go out to everyone at the same time. You don't want anyone to be able to look ahead. And then being able to do loops is kind of neat, because then you can have dynamically generated playlists that could loop round and round and continuously play the latest news stories, for example. So here we have 2 VODs put together. First, there are 3 segments from some VOD, followed by 3 segments from another VOD. And you see the paths are different from some VOD to another VOD, so we want to clean that up. And then we need the discontinuity tag. And that's sort of telling the player that the time codes in these segments might be off, so don't go and die on us, please. And this is the live playlist that we wanted to represent these merged mods. So now we still need to have the discontinuity tag in there, and the discontinuity sequence keeps track of how many discontinuity tags we've removed, and that's for syncing with the different media playlists. And we've now created another problem for ourselves. It's the mapping between another VOD and the live segment number 4. So all that, the mapping still goes into DynamoDB and our playlist information. And in order to pick that up, we get back to this one. Quite similar, but not quite. So here, the player requests live segment number 4. There's a cache miss in the CDN, triggering our Lambda again, fetching the playlist info, and now we get start time, segments, and mapping. We see that live segment 4 should map to another VOD, segment 1. But first, we check, should this segment even be visible right now, or are you trying to skip ahead? And assuming it's okay, we then get to my favorite part, I'd say. We just nudge the request a little bit before passing it on and changing what it's requesting. So instead of requesting live segment 1 before, we change the request to be another VOD, segment 1. And the really cool thing is that now, as far as the origin is concerned, it's getting a request for another VOD, segment 1. And the CDN thinks it's getting the content for live segment number 4. So we just inserted ourselves in the middle and touched the request a little bit. It's sort of like doing a man-in-the-middle attack on yourself. Just that now it's, instead of Alice and Bob, we have the CDN and the origin. Maybe we should call it man-in-the-middle routing or something. And I know it's very similar to a proxy, but subtle differences there maybe. And same advantages again, a little bit more lightweight from an ops perspective. And scaling to a certain degree is not our problem anymore. And, oh yeah, this one I've almost got. There is a handy way to pass information along, and sometimes you want to do that. Say that you want to do, you have a live event coming up, and you want to just change the start time, so you can preview it right now in live as the users would see it. Then you want to pass something along to override the start time. And how do you typically pass something along? Well, you can use cookies, headers, query parameters. They all have their problems. Cookies have been problematic for years. Headers, that means we have to be able to control the request going. And while you have the player, that is sometimes hard on certain devices to get to do that. Query parameters would work, but they tend to get lost in the playlists because you have to generate a custom response to every request. But what you can do is that you can put stuff into the URL, something like this. We can take a token and put it into the URL. And that works because, remember, we were altering the URLs anyway before sending it to the origin. So it's not like we're addressing something that isn't there. Or we were already doing that. There's, of course, a size limit, so be careful, don't overdo it. And as long as you use a JVT token, you can keep it safe from manipulation as well. My personal favorite is a token that is a preview token that says start viewing from right now, and then gives you a custom playback with a token that says right now. So you have a URL that can be there for an hour, but as soon as you start viewing it, you get the live stream from the start. Really kind of handy. So looking at what we've done so far, we created a VOD2Live with playlists, loops, and we're hiding future segments. And we did that with a sort of globally distributed data and edge computing solution, which is a very buzzword-dense sentence to use. It's just adding AI and a large language model to it, and it would be up to 2023 standards. Now it's a bit 2022 or even 2021. But It's also relatively cost effective because you can have 1,000 channels ready to go, and it's just a few cents of storage a day to have that available. And as soon as someone starts viewing it, let's say that you have a global audience, so all across the globe generating it, it's maybe 2 cents an hour or something. And if you have a more limited geography, it's a fraction of that. And when you think about cost, that's a lot cheaper than basically creating, storing, and coding all the VODs. Yeah, then viewers, as I said, it's maybe 2 cents an hour or something, or less. And that, of course, does not include viewers. If you have 1 viewer, 1 million, it's the same. But if you have 1 million viewers, your CDN costs will be a lot higher. But if you have that, ask Anders, and he can probably help you out. Yeah, and so the problem isn't that you can have almost as many channels as you like. The problem is not cost, but it's creating them. So with these tools, we can intercept, rewrite requests, all integrated into the CDN. We have a distributed state, and we can pass information along to requests. Is there something else we can do with that? And yes, it is. We can tackle the problem of credentials sharing. And this will be very close to the previous feature. It's not quite up to Netflix standard. We're not tracking devices. That you probably do better at login. But we can control concurrent viewers. And we can do something like this. Start by injecting a JWT token into the player. And if you have login that authenticates with JWT, you can use that one. The only thing we really need to know is which account is this for. The player puts it into the URL that is then requested to the CDN. And now it becomes trickier because we have to do this for every request. So it's not origin request anymore, it's on user request. So for every request, we need to go in and see who is calling, are they allowed? And we trigger a Lambda, we then go to our database where we keep a store of who is watching from where and on which device. So given the account that we get from the token, we check the device in the request against the current device. And here, device fingerprinting is, well, longer than 2.5 minutes to explain, but see it as IP and user agent for short. And basically 3 things can happen: the requesting and the current match, it's all good. Or the requesting and the current does not match, but it's also not in the blocked list. In that case, update the current device. Think of the use case: you are on your mobile, on cellular, on your way home watching something, you get home, you get on your Wi-Fi, you change the IP, you don't want to be interrupted, so therefore always bump out the current if you have a new one, and then put it as a block device. And then finally, you can be, the requesting device can be in the list of block devices, in which case return an error code and have the player show the appropriate message. So this is obviously more expensive than the VOD2Live because we have to handle every request. And then it depends on your number of segments or your segment length, and live to VOD or live or VOD, because live has more requests due to the playlist. While it's not super cheap, it is still definitely doable if you have a subscription service and you either know or suspect that you have a problem with credentials sharing. This can help you prevent that to some degree. And with that, I'd like to say thank you.